Scene script. Have you ever wondered what life would be like in the fourth dimension? Our universe as we experience it comprises three spatial dimensions: length, width, and height. We move forward and backward, side to side, up and down. These are the dimensions that define the space we live in, the space we navigate every day. But what if I were to tell you that there may be more to reality than just these three dimensions? Enter the fourth dimension. It's a theoretical spatial dimension beyond the three we are familiar with. The concept of a fourth dimension is not new. It has been around for over a century, and it continues to puzzle scientists and philosophers alike. It's an idea that shakes up our everyday understanding of the world around us and challenges our perception of reality. Picture a cube. It's a three-dimensional shape, right? But what if we were to add another dimension to it? A dimension that goes beyond length, width, and height. It's mind-boggling, isn't it? That's because our brains are wired to perceive only three dimensions. Trying to visualize a fourth is like trying to look around a corner that doesn't exist. But just because we can't see or comprehend the fourth dimension doesn't mean it's not there. It's like trying to explain the concept of color to someone who's been blind since birth. They may not be able to see or understand color, but that doesn't negate its existence. The fourth dimension is a mystery that continues to baffle us. It's a concept that's beyond our grasp, yet it's tantalizingly close. It's a dimension we can't perceive directly, but one that could potentially hold the keys to understanding the universe in ways we never thought possible. So, the next time you're gazing at the stars or marveling at the vastness of the universe, ponder this. Imagine if we could step out of our 3D world. What would we see? To understand the fourth dimension, let's dive into the concept of dimensions. Dimensions are fundamental to the way we perceive and interact with the world. They give structure to everything that exists, from the tiniest particles to the vastness of the universe. Let's start from the very beginning. The zeroth dimension, or 0D, is represented as a single point. It has no length, no width, no height. It simply exists, a solitary speck in the grand scheme of things. Now, if we take two of these points and connect them, we step into the realm of one dimension, or 1D. This is a line, a straight path that extends indefinitely in two opposite directions. It has length, but no width or height. Next, we move on to two dimensions, or 2D. Imagine if our line decided to take a leisurely stroll perpendicular to its length. The path it would trace out forms a plane. This plane has length and width, but no height. It's like a sheet of paper or the surface of a calm lake. Now let's add a third dimension. This is where things start to get interesting. If our 2D plane decides to leap up or down, it creates a three-dimensional or 3D space. This space has length, width, and height. It's the world as we know it, the world we live in. But here's a thought. What if there's more? Imagine a world of two-dimensional beings living on their flat plane. They wouldn't be able to perceive or comprehend the third dimension, the up and down, would they? To them, our 3D world would be as mysterious and unfathomable as the fourth dimension is to us. So just as these hypothetical flatlanders struggle to understand our world, three-dimensional beings like us might have a hard time visualizing the fourth dimension. But that's the beauty of it, isn't it? There's always more to learn, more to explore, and more to understand. After all, the universe is a vast and complex place, full of mysteries waiting to be unraveled. So, what does science say about the fourth dimension? Well, let's dive into the fascinating world of theoretical physics. The concept of a fourth dimension is not new. In fact, it is a cornerstone of the theory of relativity, proposed by the legendary physicist Albert Einstein. This theory might sound daunting, but let's break it down. The theory of relativity is based on the idea that the laws of physics are the same for all observers, regardless of their position or speed. This groundbreaking concept turned our understanding of the universe on its head, introducing the idea of space-time, a four-dimensional continuum. Now you might be wondering, what are these four dimensions? The answer is both simple and complex. The first three dimensions are the ones we're familiar with in our daily lives: length, width, and height. These dimensions define the space we live in, allowing us to move forward and backward, left and right, up and down. But here's where it gets interesting. The fourth dimension, according to the theory of relativity, is time. Yes, time. The ticking of the clock, the changing of the seasons, the aging of our bodies, all these are manifestations of this fourth dimension. Just as we move through space, we also move through time, from the past, through the present, and into the future. This idea might seem abstract, but it has been widely accepted in the scientific community. Experiments have confirmed the predictions of the theory of relativity time and again, lending credibility to the concept of time as the fourth dimension. But why is this important? Why should we care about the fourth dimension? Understanding the nature of time and its relationship with space is fundamental to our understanding of the universe. It shapes our perception of reality and has profound implications for everything from physics to philosophy. Time, as it turns out, might be our elusive fourth dimension. How can we visualize this mysterious fourth dimension? It seems like a daunting task, doesn't it? But let's break it down and see if we can make some sense of it. Imagine a cube. Simple enough, right? It's a three-dimensional shape that we're all familiar with. But what if we were to take that cube and somehow, some way extend it into the fourth dimension? The result of this mind-bending exercise would be a tesseract, a four-dimensional analog of a cube. Now, the tricky part is trying to visualize this tesseract. We're three-dimensional beings living in a three-dimensional world, so our brains aren't naturally equipped to understand or visualize four-dimensional objects. But that doesn't mean we can't make an attempt. Let's use shadows as an analogy. When a three-dimensional object casts a shadow, it's represented as a two-dimensional shape on the ground. Similarly, a four-dimensional object, like a tesseract, would cast a three-dimensional shadow in our world. So, if we were to see a tesseract, it might appear as a strange, constantly changing three-dimensional shape. It might seem to be twisting and turning in impossible ways, as the different aspects of its four-dimensional form cast their shadows into our three-dimensional world. And just as the shadow of a cube can't fully capture what a cube is, this shadow of a tesseract won't fully capture what a tesseract is either. But it gives us a glimpse, a hint, of what the fourth dimension could be like. It's like trying to understand a story by only reading a single paragraph. You won't get the full picture, but you can start to grasp the ideas and concepts. So while visualizing the fourth dimension is challenging, it's not entirely impossible. It requires a bit of imagination and a willingness to step outside of our three-dimensional comfort zone. But isn't that what makes exploring the mysteries of the universe so exciting? Visualizing 4D might be challenging, but it's not entirely impossible. What does the fourth dimension mean for us in practical terms? This question, while seemingly abstract, carries with it a weight of significance that reaches into various fields of human understanding. Let's start with physics. The fourth dimension introduces a new layer of complexity to our comprehension of the universe. It's like adding a new color to an artist's palette. Suddenly, we have a whole new range of possibilities to explore. Quantum physics, for example, often invokes higher dimensions to explain phenomena that seem paradoxical in three-dimensional space. Theories such as string theory, which proposes that fundamental particles are not zero-dimensional points, but one-dimensional strings, require the existence of additional dimensions to make mathematical sense. Next, we delve into the realm of mathematics. The fourth dimension provides a playground for mathematicians to explore concepts that extend beyond our physical reality. It's a mental exercise that pushes the boundaries of human cognition, helping us to develop new mathematical tools and techniques. The study of four-dimensional shapes, or 4D polytopes, has led to advancements in areas like computer graphics and data visualization. Lastly, let's consider philosophy. The fourth dimension, with its inherent challenge to our perception of reality, stirs philosophical debate. It forces us to rethink our understanding of space and time and confront the limitations of our senses. Philosophers and thinkers have pondered over the fourth dimension, using it as a metaphor for exploring ideas about reality and human consciousness. So, while the fourth dimension may seem like an abstract concept, it's far from irrelevant. It's a lens through which we can view the universe from a different perspective, pushing the boundaries of our knowledge and understanding. It invites us to question, to explore, and to imagine. It's a testament to human curiosity and our relentless pursuit of understanding the world around us. The fourth dimension as abstract as it may seem, has profound implications for our understanding of the universe.